Well, hopefully you're feeling a bit more comfortable working with Raptor and you're kind of getting the hang of that and how to create procedures. What I'd like to do in this video is take a look at the same example that we had in the text, the one that starts on page 104, passing an argument by reference, and see how we can take what we did in Raptor with the flowchart and now translate that into C++ code. If you remember, we had our main procedure, and then we had three other procedures. We had show intro, get cups, and cups to ounces. So each of these has a specific purpose, and then our main procedure was going to call each one of them in sequence. So we start out by declaring our cups needed local variable within main. Then we're going to call show intro, and that's going to print out some introductory information about what's going on in this program. Then we're going to call get cups, which is going to get the number of cups from the user, and then convert the cups to ounces and display our output. Okay, so let's go ahead and we're going to go ahead and start C++. So right here is my Visual C++. And if you remember the steps, we're going to create a new project. And it is a Win32 console application. Down here at the bottom I'm going to put in a name, and this is my, how about if I do my program, what was this, 3-10 example. Remember, we're always trying to put in meaningful names. Here I'm going to save it in that same My Assignment Solutions that I used previously. If your location isn't showing the location that you want, you can browse to find it. And make sure this Create Directory for Solution is turned on. That's going to be important for you to be able to get all your files together to send them to me. So make sure this checkbox, Create Directory for Solution, is on. Okay, we'll click OK. Now before we move on, we need to click on Application Settings, and we want to click on the Empty Project checkbox. This should also already be set to Console Application, but we want Empty Project. Now we can click Finish, and we are almost ready to go. At this point we have our project, but we don't have our C++ file to work with. So I can right-click on Source Files, and if you're not seeing this, it may be closed up. You just click on your little arrow and that's going to open it up so that you can see source files. I'm going to right-click and I want to add a new item, and what I want to add is a C++ file, and our first one we're going to call main. So two different names we're using, one name for the project, another name for the C++ file, so don't get those two confused. The overall name for the project I give you in the assignment notes, and it usually has to do with the chapter and the exercise, and you also have your name included in the name of the project. When we create the C++ file, this is where we're just going to call it main. This is going to be standard every time. So click Add, and you'll see we have our main C++ file that's been added. And we always start out with documentation. So the documentation that we're going to put in is double slashes, and then we always start with our name. And remember, I told you this is going to vary depending on the company that you're working for and what they want. So I just want to identify this program, when it was created, and I want to tell what it's doing. So this program requests an amount measured in cups, converts this to ounces, and displays the result. Now I like to keep spacing in my program so that things aren't running together. It makes it much easier for anyone who's looking at the code to try to figure out what's going on. So next thing we put in is our include IO stream. And remember that we also want to add using namespace std, and that's going to give us the ability to do our input and output without having to add extra information to our code to be able to get to those commands. Okay. Now, if you've looked at the examples in your C++ language companion, you'll see that we do something called setting up function prototypes at the top of our code. This isn't anything that really defines what the function is going to do, but it does tell C++ that we are going to have these functions later on within our code. So it just kind of, I think the verbiage that was used in your companion was that it declares the existence of a function. So we are going to declare the existence of our functions. So if we want to look back at Raptor, we can see what we had here. So we had 3 different functions that we're going to declare. We have showIntro, and showIntro, you'll remember, we do not use any arguments. We're not going to pass any arguments. It does not have any parameters that it's using. GetCups, we're going to pass an argument to it, and we're going to pass that one, if you remember, let's see, we're going to pass this so it goes in and out. So that's passing by reference because we want to change it within this function. So we need to remember that we're going to pass an argument by reference. And then when we come over here to cups to ounces, this one also has a parameter called cups. But if you remember with this one, we're not going to do anything with it except read it, be able to do our calculation, and then output a value. We're not going to change it at all. So we can pass this one by value. It's only coming in. We don't need to send anything back out. So we're going to pass the argument into this procedure. We're going to pass it by value. This one we're going to pass by reference because when it comes in, we're passing the argument in. So it comes in here to this parameter, cups, and then within here we're going to get a value. That value has to go back to main. Because it has to go back to main, we have to actually change it. So that's why this one's being passed by reference, this one's being passed by value. Okay. So let's go back to C and see if we can get these set up. Okay, I'm going to put a comment in just to say that this is my function prototypes. And our first one, these are always going to start with void, and for now just understand that that's what we're putting in. We don't need to think about what it actually means. It's just something that we need to do. showIntro is our first one, and it has no parameters, so we just use our 2 parentheses, and we do have to end this with the semicolon when we're doing our prototypes. Okay, then we're going to do void. Oops, we already did showIntro. We're on to getCups. And this one, you remember we used real when we were working back in Raptor. The equivalent to that is float when we're working in C++. So I'm going to use float, and that's going to allow us to use decimal values. So we could pass to this something like 2.5 cups. We can have a part of a cup. We're not working with integers. So float, and we're going to call this cups, but to say that this is being passed by reference, we have to add an ampersand to the beginning of it. Now, if you'll take a look into your language companion, the C++ language companion, and let me see, look over, let me find this real quickly for you. I want you to see where it's working at passing. Oh, this is on page 25. If we look at page 25, in program 3.5, it's showing you where it's passing by reference. And the function prototype that's on line 5, it says void set to 0, and then within parentheses it has integer and just an ampersand. That ampersand says that it's going to have something passed by reference. What I've done is define this as float and then ampersand, and I've added cups. This cups did not need to be there. I could have taken that out and just had the ampersand, but I think it's easier to understand if we actually put our argument, put our parameter, I'm sorry, get the right terminology for you here, put the parameter name in here. So by putting in cups, I think it will be just a little bit easier for us to understand. And then I'm doing void cups to ounces, and this one we're also passing cups, but in this case, remember we said that this one can be passed by value, so we are not including the ampersand in front of cups. And again, I did not have to have cups included here. You can leave that out, but by putting it in, I think it just makes it a little easier for us to follow what's going on. And now there are a lot of different ways that you can approach putting your code together. I'm going to go through and just do our main procedure first, since we're just doing our calls there, and it will let us do that within C++. Remember, we couldn't do that when we were working in Raptor. We had to actually have all those procedures defined first. But here I can do my main function, and it will let me do the calls. So I'm doing int main, and we need our curly braces. And I'm going to try to document this pretty well so that you can tell what's going on. So I'm going to declare a local variable to store the number of cups, and this is going to be entered by the user. And I'm declaring cups needed. Cups needed, if you remember, is the variable that we used within the main procedure. If we look back here to Raptor, within main, we were using cups needed. Now when we pass this, the argument is passed as cups needed. Here when we look at get cups, we go over to get cups, it actually comes in as cups. And remember, these names do not have to match, it's by location. So because this is the first parameter, and because in main it is the first argument, the argument matches up with the parameter and it passes that value. Because this is by reference, it's actually looking at that same location, and it's being able to change the value of it and send that back. I'm sorry, I'm not going real smoothly here when I'm talking through this, but I hope you can catch what I'm trying to get across. Okay, so cups needed is what it's going to be called in main, but when we look at get cups, it is going to be called cups, but it's all the same thing. It does not matter that those names don't match because the positions do match. So float cups needed, and then we're going to start calling, so we're going to do call a function to display an intro. And I'm not sure why it indented that further for me. It does not need to be indented like it was. And we're going to call show intro. This does not have any arguments. So we're just calling show intro. And you'll see it shows that there's an error at the moment, these little underlines. That's okay. Once we define the function down further in the code, those little squiggly lines will go away. And then we're going to call the function to get the number of cups from the user, and that's our get cups. And get cups, we're going to need to pass this cups needed to it. And you'll see, even though we're passing this by reference, there's nothing that we need to do. There's nothing that looks different when we actually call the function. Because when we define the function get cups, we're going to identify the parameter as being by reference, this ampersand. That's what takes care of making sure that it is by reference. Okay, so then we're going to call our last function to convert the cups to ounces and display the result, and this is cups to ounces, and we're also going to pass cups needed to this. And you'll see it looks no different here whenever we call the different functions. It doesn't look any different whether we're calling and passing the argument by reference or by value. It looks the same. And then we need to remember our return and our closing curly brace. And we are finished with main. Okay, then we move on to doing our first function, which is going to be our show intro. So let me just say a little bit about this. So the show intro function displays an introductory message to indicate the purpose of the program. And remember I told you this is void. And we have no parameters for this one. And we're just going to send to the output some text. And remember, we have to add the end line. If we don't add the end line, it's going to run everything together, and we want these to print out on separate lines. Oops. Did you catch that I missed something whenever I was doing this? Did you see that our curly brace was missing from up here? We always have to have curly braces, even for our functions. So now I think we should be back on the right track. And the text that I'm doing here is what we did in Raptor, and it was what was listed in the text, so that's why I'm breaking these up into the segments that I am. Okay, and I think that should do it for our show intro. So show intro, all we're doing is 3 lines of text that we're going to print out. That takes us to get cups, so let's say a little bit about that. The get cups function. Prompts the user for the number, not spelling very well today here, for the number of cups. And again, this is void. And try to be consistent even in your documentation with your capitalization and all, so that things are matching up correctly. So get cups, and the parameter for this one is float. And it is being passed by reference, which means that whenever cups comes into this function, we're going to be able to modify that same variable, and it's going to get sent back out and go back to main changed. If we don't pass by reference, if we pass by value, if any changes are made to the variable within the function that's called, those changes never get back to the calling function. So we do want this change to be able to get back, so it is by reference. So void get cups, and we are going to do a prompt, and for our prompt we'll say enter the number of cups Oh, and you see what I missed again. If we don't have our curly braces, it's not going to work correctly. And you'll see I'm keeping things lined up. And it's really important that you do keep your text, your lines of code lined up. That's going to make it much easier when you go back through and try to figure out what's going on. And then we need to get input, and our input is going to go into this cups variable. And let's finish up here with our curly brace. And we have one more to go. We need to do our cups to ounces. So the cups to ounces function converts cups to ounces and displays the result. And this is void cups to ounces. We're using float again so that we can have decimal positions. This is not passed by reference. This is passed by value, so we do not put the ampersand in front of cups. Now let's see if I can remember my curly brace to begin with this time. And we are going to declare a local variable to store the result of the conversion from cups to ounces. And this is float ounces. And we're going to set it to 0. And then our calculation is ounces is going to be equal to cups times 8. And you'll remember we said we're just going to type in the number 8. It's a literal. We don't need to set up a constant that we're going to be, because we don't really need to ever change that value. It's always 8 ounces in a cup. So in this case, we can just type in that literal and that will work absolutely fine. But if you're going to use something like a percentage, some sort of rate, then you should create a constant up at the top of your code. In this case, we could have done it just within this function. We could have created a constant at the top of the function so that we could, if we needed later on to be able to change this, that we could change the 8 to something else. But 8 is always the number of ounces in a cup, so we just need to type that in. And then for our output, we're going to write to output. I'm going to do an end line first so that we have a little bit of space in between here. And then we're going to say that converts to, and you'll notice I'm leaving a space, and then we want to put in our ounces. That's our variable, and then the word ounces followed by a period, and you'll see I left a space before the O. You'll notice I have some wavy lines here. The wavy lines are telling me that there's a problem, and you'll see I missed something when I was typing this in. So always as you're working through and putting your code in, if you see wavy lines, that's something that needs to be addressed. So when I go back, it says it expected a semicolon, so it's saying that something else should have ended than this before this started. But if I look, it's really not a semicolon. I just didn't have my symbols in to be able to send things to the output stream. So now I have cout, my end line, that converts to, and then to that I'm adding ounces, and to that I'm adding the word ounces, and then my end line character, and it looks like it's happy now. And I can finish this up with my close curly brace, and I think we have got it. So let me click Save All and make sure I have all of this saved. And let's just go back and review what we have. So we started out, we want to comment everything. We have our standard statements that we have at the top, our IO stream and our namespace. Then we do our function prototypes, and our function prototypes are showing that we're going to have 3 functions that are going to be called. The first one has no parameters. The second one has cups that it's going to be expecting to receive. It's float, which means that it can have decimal positions. And the ampersand indicates that it's being passed by reference. So cups is going to go into the getCups function. It can be changed within getCups and come back to the calling function, which is going to be our main function. Cups to ounces is also going to have a cups parameter. So it's going to expect something to be passed to it. But when this is passed, there is no ampersand. So this is saying it's being passed by value. That means that the value that's held in cups is going to be passed into cups to ounces, but nothing is going to come back out of it. The function that calls cups to ounces is not going to be able to get a value back within cups. Cups is going to be unchanged. So we'll look at main, and main is going to declare cups needed. This is the local variable, and this is what's going to be used to be able to communicate with the various functions that are being called. We're going to call show intro. We pass nothing to it, get nothing back from it. It has no arguments, but we must use parentheses because functions always use parentheses. So show intro is called. It's going to print out our text. And then we're going to call the function to get the number of cups from the user. So we're calling cups needed. We're calling get cups. We're passing cups needed. That's our argument that's being passed here. Our argument is going to match up with the parameter cups, and it is being passed by reference. So when we're down here in get cups, and let's just scroll down and take a look at it, within get cups we're going to ask the user to enter the number of cups that's going to be stored in cups, which is our parameter that's listed right here. When we come up here to where this was called, it's going to come back into cups needed. So now cups needed is going to have the value that the user entered. Cups needed can then be passed to cups to ounces. Within cups to ounces, it's being passed by value. That's going to come in. We will have cups needed is going to be passed in here and called cups within cups to ounces, so that whenever we go to print this out after we do our calculation, we're going to have that value from the user. It's going to be multiplied by 8, put into ounces, and that's what's going to get printed out. So let's go ahead and try to run this. Remember, we're doing debug, and we're going to do start without debugging and see what we get here. Uh-oh, there were build errors. What do we have going on? Syntax error, we are missing a semicolon before identifier show intro. So let's take a look at what's going on there. So let me take a look and see what's happening. Up here. Okay, so this is going to happen sometimes. See what we did? We have float cups needed, and we needed to have a semicolon there, and I missed putting that in. Okay, let me try it again. Okay, looks like we had success this time. So this program converts measurements in cups to fluid ounces. Ooh, I think I missed something here. For your reference, the formula is. I actually missed a line of code, so I'm going to need to go back and put that in. But 1 cup equals 8 fluid ounces. Enter the number of cups. So if we say we have 2 cups, and it comes back and says that converts to 16 ounces. Now, I would probably work with this a little bit and go back, and maybe I would add some more end lines to be able to space out my output. So let's see what we can do with that. Okay, first of all, it looked like I was missing some code. And let me see. In cups to fluid ounces, there's actually something else that goes in here. Cout. I was missing reference, the formula is. And I think I'll add an extra end line here just to see how that's going to work. It should space things out a little bit better. And let's try that. Okay, so this program converts measurements in cups to fluid ounces. For your reference, the formula is 1 cup equals 8 fluid ounces. And here I probably want to put another end line in to space this out a little bit. Enter the number of cups, 2 cups, that's 16 ounces. So yeah, I think I'll probably go back. Oh, and I have a typo here too. Number is N-U-B-M-E-R. That's not correct, so let me go back and fix that. So you'll see after you do your program the first time, you do need to go back through and check things, make sure they really are working, that your output looks good. So where I have 1 cup equals 8 fluid ounces, I want to add an end line to that and then correct my spelling of number. So 1 cup equals 8 fluid ounces. Add an end line to that and enter the number of cups. Okay, I think we may have it this time. Let me give it one more shot. Okay, this program converts measurements in cups to fluid ounces. For your reference, the formula is, and then we have some nice spacing in there so that this stands out a little bit. We have some spacing before enter the number, which is spelled right now, number of cups. Let's try 5 cups this time. And then we have a little bit of space, and that converts to 40 ounces. Press any key to continue. If I were going to do anything else to this, I might add another end line just so that I have space before this press any key to continue comes up. But that's it. Hopefully that's helped you understand a little bit better how you can take what we've already done in Raptor with the example from the chapter and how we can implement that using C++ code. And you'll see that doing your code, you do have to do your planning ahead of time, but even when you plan, when you're entering your code in, you can have little errors here and there. So always be watching for those wavy lines. Check down here in your output window to see if you have any errors there that it says you need to take care of. And then just do your editing as needed and just keep at it. Debugging is as much a process as writing the code is. And as always, if you have any questions, please feel free to get in touch with me. And remember that we do have a tutor available for you too. We're here to help you out. Biggest thing is, don't wait to the last minute to get started, because if you do, then you don't have time to get assistance and you're rushing and you don't really have the time that you need to work through and fully grasp the concepts that we're working on. Hope your project goes well.